So let's get started with coding. First step is activate the Docker path. Okay, let's just activate it. So it's been activated. Secondly, we have to use the pip install to install the magic Docker. Pip3 magic Docker. Great. And now we have to open one Jupyter file and run the model. So let's start with this one. Jupyter notebook. So here in the desktop, I have one project to work, Magic project. In Magic project, I have two model and two database. And I would like to containerize this model with the Docker to be able to use it for long term, or maybe I wanted to send my client. So let's see what we have here. A supervised learning model. There is one training session that I used to create a couple of months ago. And let's see whether or not it is starting right now. So we can see because my machine doesn't have this library, so I got this problem. The model cannot work because we have some missing library here. So let's start with Docker and create our own magic Docker function to containerize it. For this one, we said, okay, let's call it import. So it's imported, and now we have to call it. There is a function for the J magic Docker because it works for the Jupyter, so that's why I have a J here. And that's it. We finished with the coding, and now the models take care of everything. First of all, it shows that the one file chooser for us to select our model. So I have two models. Let us start with the test. In the test, the model said, okay, there's a two library, NumPy and Pandas. If we have one more model, we can add more. If not, we can continue. So I have one more file to add. Here it is, supervised learning. And say, yeah, I found two more library. Let's add it. Matplotlib and scikit-learn. So, and I don't have any other library to add, but if you have, you can add more. Here, just the model analyze our file, find these two libraries that's been installed in my computer and the appropriate version for the file. So it selected this one, and the two libraries that not installed in my machine, but the file needed. So find them, but couldn't find the version because there is no version in my computer. It's been added in the requirements. We talk about these requirements a bit later. And then I mentioned Dokerfile is a text file that shows our step that the Docker is supposed to use to generate our uh, Docker image or container. This is the contents that the model generated for us. Let's take a look at it. It started with the Ubuntu. If you want it, you can change it. I like Ubuntu. So let's start it. And then created one virtual environment for us and install the Python version 3. If you wanted something else, you can edit it. It's all customizable. And then started to create one directory. I rather to work with the source. If you want it, you can change it. Everything you want, you can change and customize it. But remember, do not change the name of them. If this is a requirements, and do not change it because the requirements file will be added to your model. Here it's been going to install the pip3 install from the requirement. Whatever library that you wanted, you add here. Maybe some of them is not detected with the model, so you can add manually if you want it. And the model will be added based off your order. And here we can see the model expose one port 8888, and then it's run the same exposed port to run the Jupyter notebook at the end of the day. When we generate this Docker image and we call this Docker, the model will be read this one, and when you call the Docker file, it would be the Jupyter notebook with port 8888, and then the Jupyter file will be pop up for you. And yeah, if you want it, customize it, you can customize. If not, just accept it. Now it's going to create our container. It's take the 5 to 10 minutes because it have to load the Ubuntu ISO file from the Docker hub and then regenerate it in your Docker. So it's a take the file and also installation for this library take time. Let's see what happened in the background. You can see line by line is going to read the file, the Docker file, and create the file that we want. Yeah. So here we can see the model works line by line and all steps been done, and yeah, successfully generated the image Docker for us. So let's see where is the image. To see the image, we can use of the Docker file here. If you guys see the Docker images, it shows the latest image that we have. It's take a bit time, so the latest one is here. We can see the Docker supervised learning workstations, and this is the ID that we have here right now. You can see the same IDs here, 22. It would be our model that we generated. Whenever you want it, we can call either image ID or the name of the Docker that we have. So let's see what file exactly generated for us and how it's working. It was my drive that I was working. I had these two files, supervised learning and one test file. So these files are generated with Docker. Docker file, the zip and the isolated file as a Docker that I isolated, then you can share this file with your client or send it to any cloud environment to work with this, or also you can push it in the Docker hub. And one permission that it generated the Docker for us, and one Docker run. Then if you run this file, the Docker will be run for you, and this is the command that you have to run it. Docker run, we call the port that we expose and the name of the Docker image that we have. So let's see what the Docker file is in there. Docker file, it's a text file. Basically, it's a text file that we mentioned that we all add all steps for our model here. First, we call the Ubuntu as baseline. Then we generated one virtual environment and install Python version 3 on it. Then we created one source dictionary, one source folder, and copy all the requirement inside the folder because we have to be able to run it. And then we install all the requirements or the library that we wanted, and then we install the Jupyter notebook. When we install the Jupyter, then we expose the ports that we wanted to work with that because Jupyter needs appropriate port. We call the model, okay, what port we working and what port would be the listening. I just use of the same port, 8888. You can set for your own port if you want it. And this is the command line would be the last part of our model. When we call this model, directly open the Jupyter notebook using this port and expose your model. So let's see how it's working. So Magic Docker also generate one bash file for us to run the Docker. Let's see what is inside. You can see the Docker command is here to run our Docker image. Docker run port 8888 and Docker image name. Let's run it. And let's see with the shell command we run this file. Yeah, we can see the Docker it exposed the same port that we had. So generate a token for us. And here, let's run. Also, let me open one Jupyter file as well. So here is our folder and our file in the Docker. And let's open one Jupyter file from my computer. To compare both files at the same time. And here we can see my original file from my computer. Let's open the supervised learning. And you can see because the library of the matplotlib is not here, I cannot run the file because the library is missing in my computer. But what happened in the Docker image? We install everything. Let's see whether or not we are able to run the model. And we can see, yeah, perfectly, the model is run and we can do our processing. So you saw how easy we can generate our own code-free and error-free Docker image, and we can share with our colleague, we can share with the client or customer, or even we can secure and zip our file in the repository to save for the future. So guys, if you like my video, just don't forget, give me thumbs up. Have a good day.